Hello everyone, welcome back. So in this lecture, let us discuss about the binomial option pricing model. The binomial option pricing model, or the BOPM, was developed in 1979. The reason it's called binomial is because at every step, the price of the underlying asset can go up or down. So it's like a tree that grows two branches at each step. You can imagine it as a path where the asset price has two possibilities. It can either go up or go down. So, in this model, we make a few simple assumptions. The first assumption is that there are only two possible prices for the asset, an up price and a down price. The interest rate remains the same throughout. And the next assumption is that markets are assumed to be frictionless, meaning there are no transaction costs. And investors are assumed to be risk neutral, which means they don't mind taking risk as long as they are compensated fairly. So, the beauty of this model is that it works by breaking down the time period of the option's life into smaller, manageable steps. It makes the valuation process much more flexible. So, let us start solving some problems to understand the binomial option pricing model better. Imagine you want to buy a call option for Wipro Limited. The current price of Wipro's share is rupees 300 and the strike or the exercise price, that is the price at which you can buy the share, is rupees 340. The call option expires in 1 year. There are two possible prices for Wipro share after a year. One, if the market goes up, the price could be rupees 350. If the market goes down, the price could be rupees 250. The risk-free interest rate is 7% per year, annual compounding. Now here our task is to calculate the fair value of the call option today. So here is a binomial option pricing formula for finding the call option premium. The binomial option pricing formula finds the value of an option today. It does this by combining the possible future values if the price goes up or down. Then it adjusts these values using probabilities and brings them back to the present value using the discount factor. So here the C is the premium of the call option at present. CU is the value of call option on expiry when the price goes up. CD is the value of call option on expiry when the price goes down. So in order to find the probability of price going up and down, we use the formula I minus D by U minus D and U minus I by U minus D, where U is the high probable price by spot price and D is the low probable price by spot price. We finally divide the numerator by I to get the expected present value of the option. I here is 1 plus the risk-free interest rate. Now let us input the values in the formula. The step 1 is to define the up and down factors, that is U and D. The up factor tells us how much the stock price increases in the up scenario, and the down factor tells us how much it decreases in the down scenario. So here U is equal to 350 by 300 equals 1.16. D equal to 250 by 300 equals 0.83. And I is equal to 1 plus 7%, which is 1.07. The given high probable price is 350 and low probable price is 250 and the spot price is 300. Let us input the values in the formula. The step 2 is a risk neutral probability. So this is the fancy way of saying what is the probability of the stocks moving up or down adjusted for the risk-free interest rate. Now the probability of price moving up is I minus D by U minus D, which is 1.07 minus 0.83 divided by 1.16 minus 0.83. So the answer here is 0.727. The probability of price moving down is U minus I by U minus D, which is 1.16 minus 1.07 divided by 1.16 minus 0.83. And here we get 0.273. Step 3 is to find the payoffs in the up and down scenarios. If the stock price goes up to rupees 350, the call option's value is maximum of spot minus strike or 0. So maximum of 350 minus 340 or 0 gives us rupees 10. If the stock price goes down to rupees 250, the call option's value is maximum of spot minus strike or 0, which is maximum of 250 minus 340 or 0 gives us 0. So why rupees 0? Because the option would lapse if the share price is less than the strike price or the exercise price. And the step 4 is to compute the fair value of the call option. Now we combine these payoffs to calculate the today's fair value, where we use the formula Cu into I minus d by u minus d plus Cd into u minus I by u minus d, the whole divided by I. Let's plug in the values in the formula. So 10 into 0.727 plus 0 into 0.273 divided by 1.07. So this gives us the answer 6.79. So the fair value of the call option is 6.79. This means if someone offers you this option for rupees 6.79 or less, it is a good deal. If it is priced higher, you might think twice before buying. Now, let us discuss few more problems for better clarity. So suppose the current share price of HAL is rupees 4,600. At the end of each quarter, there is a 40% probability that the share price will increase by 70 rupees and 60% probability that the share price will decrease by 30 rupees. A 6-month call option is available on the share with a strike or the exercise price of rupees 4,620. The risk-free interest rate compounded continuously is 8%. Calculate the present value of this call option. Okay, so let's try to understand this problem step by step with a visual in mind. Imagine we have a contract for 6 months and this period is divided into 2 quarters. So we start with the current stock price, which is 4,600. At the end of the first quarter, the stock price has two possibilities. It can either increase to 4,670, that is 4,600 plus 70, or it can decrease to 4,570, which is 4,600 minus 30. So these are the two outcomes after the first quarter. Now let us move on to the second quarter. If the stock had increased to 4,670 in the first quarter, it can either increase again to 4,740, which is 4,670 plus 70, or it can decrease to 4,640, which is 4,670 minus 30. Now, similarly, if the stock had decreased to 4,570 in the first quarter, it can now increase to 4,640, which is 4,570 plus 70. Or it can decrease further to 4,540, which is 4,570 minus 30. So by the end of the 6 months, there are three possible outcomes. The stock price can be 4,740 or 4,640 or 4,540, depending on how it moved in the 2 quarters. So this step-by-step process forms a tree-like structure, which we call a binomial tree. It's a simple way to map all possible price movements over the contract period. Now, let us start working backward to find the fair value of the option. Let us begin with the final nodes of the binomial tree. So Cu and Cd is calculated based on whether the option is exercised or not. If the price moves up to 4,740, the option's payoff is maximum of spot minus strike price or 0, which is maximum of 4,740 minus 4,620 or 0, which will give us 120 rupees as the payoff. If the price moves to 4,640, the option's payoff is maximum of spot minus strike or 0, which is maximum of 4,640 minus 4,620 or 0, which will give us the payoff as 20. Now, if the price drops to 4,540, the option expires worthless, so the payoff here is 0. That is, maximum of 4,540 minus 4,620 or 0 gives us 0. Now, we move on to the next step in the tree. Unlike the previous problem, here they have directly given the probabilities of price going up and down as 40% and 60%. So we don't have to find it again. So that is 120 into 40% plus 20 into 60% divided by e to the power 8% into 3 by 12 gives us 58.81. So the weighted average of these two payoffs is calculated and its present value is computed. Similarly, it is done for the down node, which is 4,570. So from 4,570, there are two possible outcomes. So which is 20 into 40% plus 0 into 60% divided by e to the power 8% into 3 by 12. This gives us an answer of 7.84. So finally, we have come to the starting node at 4,600. So the options value here is calculated by combining the values at 4670 and 4570 using the probabilities of moving up or down. There is a 60% chance of moving up to 4670 where the value is 58.81 and 40% chance of moving down to 4570 where the value is 7.84. Now let us find the weighted average and discount the values back to the present level. So here 58.81 into 40% plus 7.84 into 60% divided by e to the power 8% into 3 by 12 gives us 27.669. So this shows how we use the binomial method to calculate the options value by working backward from the final payoff step by step. Let us work on another different problem to find the fair value of the put option this time. Let's say the current value of Nifty 50 index is 26,000 points. At the end of each quarter, it may go up by 10% or down by 15%. A European put option contract is initiated for 6 months period with an exercise price of 26,200 points. And the continuously compounding risk-free interest rate is 7% per annum. So let's calculate the value of European put option using multi-step binomial option pricing model. Okay, so here let's try to understand this problem step by step through a binomial tree. So imagine we have a contract for 6 months and this period is divided into 2 quarters. So we start with the current Nifty index value which is 26,000. At the end of the first quarter, the index value has two possibilities. It can either increase by 10%, that is 26,000 into 1 plus 10% gives us 28,600. Or it can decrease by 15%, which is 26,000 into 1 minus 15% gives us 22,100. So these are the two outcomes after the first quarter. Now, let's move on to the second quarter. If the stock had increased to 28,600 in the first quarter, it can either increase again by 10% further, which is 28,600 into 1 plus 10% gives us 31,460, or it can decrease by 15%, which is 28,600 into 1 minus 15%, which gives us 24,310. Similarly, if the index had decreased to 22,100 in the first quarter, it can now increase by 10%, which is 22,100 into 1 plus 10% gives us 24,310. Or it can decrease further by 15%, which is 22,100 into 1 minus 15% gives us 18,785. So by the end of 6 months, there are three possible outcomes. The Nifty index can be at 31,460 or 24,310 or 18,785, depending on how it's moved in the past 2 quarters. Now, this is a simple way to map all possible price movements over the contract period. Now, here is a formula to compute the fair value of the put option. P refers to the premium of the put option at present. PU is the value of put option when the price goes up. And PD is the value of put option when the price goes down. Now, in order to find the probability of price going up and down, we use the formula e to the power RT minus D divided by U minus D and U minus e to the power RT divided by U minus D. So here in the place of I, we are using e to the power RT as it is continuous compounding and not annual compounding. So where U is the high probable price by spot price and D is the low probable price by spot price. We finally divide the numerator by e to the power RT to get the expected present value of the option. Now let us input the values in the formula where U is equal to 28,600 divided by 26,000 gives us 1.1 and D equals 22,100 divided by 26,000. Now e to the power RT is e to the power 7% into 3 by 12 gives us 1.0176. Let's plug in the values in the formula. 1.0176 minus 0.85 divided by 1.1 minus 0.85 gives us 0.67, which is 67%. So the probability of price going up is 67%. And the probability of price going down is 1 minus 67%, which is 33%. Now, let us start working backward to find the fair value of the put option. Let us begin with the final nodes of the binomial tree. PU and PD is calculated based on whether the option is exercised or not. If the price moves up to 31,460, the option payoff is maximum of strike minus spot or 0, which is maximum of 26,200 minus 31,460 or 0, which equals 0. So here the option will expire worthless as the payoff is 0. If the price moves to 24,310, the option's payoff is maximum of 26,200 minus 24,310 or 0, which gives us 1,890. If the price drops to 18,785, the option payoff is maximum of 26,200 minus 18,785 or 0, which gives us 7,415. Now let us move on to the previous quarter. So let's plug in the values in the formula where 0 plus 1890 into 33% divided by e to the power 7% into 3 by 12 gives us 612.9. So here e to the power 7% into 3 by 12 is 1.0176. So here the weighted average of these two payoffs is calculated and its present value is computed. Similarly, it is done for the down node, that is 22,100. From 22,100, there are two possible outcomes, which is it can go up to 24,310 where the payoff is 1,890, or it can come down to 18,785 where the payoff is 7,415. So 1,890 into 67% plus 7,415 into 33% divided by 1.0176 gives us 3,649.02. So finally, we have come to the starting node at 26,000. The option value here is calculated by combining the values at 28,600 and 22,100 using the probabilities of moving up or down. So there is a 67% chance of moving up to 28,600 where the value is 612.9, and a 33% chance of moving down to 22,100 where the value is 3,649.02. Let us find the weighted average and discount the values back to the present. So 612.9 into 67% plus 3,649.02 into 33% divided by 1.0176 gives us 1,586.89. So this is the fair value of the put option. So this shows how we can use a binomial method to calculate the put options value by working backward from the final payoff step by step. So we have come to the end of this video. I hope you understood the concepts well. Thank you. See you in another one.